Hi, so my name is Lean. We are going to be talking about our blockchain final project in the online special topics and information science course, INFOST691, section 211. So what is blockchain? Blockchain is basically a chain of blocks that contains information. It's made for maximum security, and it's not necessarily the transactions themselves, but it is the record of transactions. It's used for to be able to secure the transfer of items like money, property, contracts, without requiring a third party like a bank or the government. It's able to have multiple entities, which is able to, instead of having one entity where it can be hacked or the information can be tampered with, it is made to also be able to trade directly with each other rather than one person, so it facilitates peer-to-peer exchange. So with blockchain technology, it dates back to about 2009 when it was created to manage the cryptocurrency of Bitcoin. And basically, the term blockchain 3.0 hasn't really emerged, and the concept doesn't appear to be clearly defined yet. But the technology is expected to improve medical record management and the insurance claim process, as well as accelerate clinical and biomedical research and advance biomedical and healthcare data ledgers. So it's one of those things where it's not necessarily well known yet, but we are going to dive deeper into blockchain 3.0 in the health field.
The next two slides will go over the potential stakeholders. To start off, I would just like to define kind of just what a stakeholder is. It's kind of an individual or a group that has, who's going to be impacted by the outcome of this project, or just like any activity of the organization itself. So capitalizing on this technology just has the potential to connect fragmented systems to generate insights and to better assess the value of care. In the long term, a nationwide blockchain network for electronic medical records may improve efficiencies and support better health outcomes for patients. To start off, we can talk about kind of just like physicians or care providers, and just talk about how they complete view of individual health histories by using health records, the clinical care coordination itself, which can help physicians in effective management of emergency medical situations. There's just greater collaboration within the research communities and just overall safe streamlining of the electronic medical records information, just transferring patient data from one provider to another. Moving forward, talking about the clinical research, there's going to be increase in drug supply chain, checking drugs and counterfeit drugs, managing IP and R&D asset transactions on blockchain, optimizing overall marketing efforts and reduce leakages, clinical trial integrity and just the data trails, everything will be tracked. Also, hospitals are impacted, just kind of eliminating the burden and the cost of reconciliation, resulting in seamless health data exchange across health systems. That'll give a better health management, and just overall promoting value-based platforms, pay for outcomes with smart contracts, optimizing utilization for healthcare capacity and resource, and moving into patients and consumers themselves. It'll just increase patients' control over their personal health data, making them, the primary, and just making sure that any direct payment of incentives and health tokens towards positive and healthy behaviors, they can kind of have like their own wallet to track everything. We can also use it to promote concepts such as do-it-yourself kind of healthcare things, price transparency for drug and healthcare services, and for them just to share data for research commons. Also talking about a little bit about the government and payers. This will kind of increase collaborations across government-driven systems, pooled real-time population risk, Also improve inefficiencies in billing and insurance related activities, and kind of just have a smart contracts to maintain a benefit, database to determine patient insurance and premiums overall.
For my section of the project of blockchains in the healthcare industry, I went into the sectors that are involved in this network. Of the sectors involved, they can be split into the private industry and governmental sector. In the private industry, there are biomedical research groups, pharmaceutical industries, insurance sectors, and finally, network security industry due to its need in maintaining the blockchain's protections. With the governmental sector, we have the criminal justice system that takes an interest in the legalities of human drug trials, drug falsification, and the confidentiality of patients' medical records.
After discussing what blockchain is and the parties involved, we can start to discuss how the blockchain network will be fabricated. We have to keep in mind that there are really three main applications for the function of healthcare. These include financial information, which ties into insurance as well as an individual's medical records. When it comes to clinical research, there's publishing those cases' findings and being able to retrieve the data from those findings. And lastly, we have supply chain management. For our case, we're going to be mainly focusing on pharmaceuticals, getting those drugs ordered, shipped, and distributed. Through my research, I've seen in majority there's blockchains existing only between 2 to 3 parties. I mainly think this is because of privacy and HIPAA laws. So today I will be going over the construction of a blockchain network and its code to function as a single source that could provide a universal application to an entire country's healthcare system. Starting with this infographic on our right, we can see a very simple construction of this blockchain network. These green squares will represent every individual company that functions within a healthcare system, whether it's a drug manufacturing company, distribution company, hospital, clinic, insurance company, the government, the list goes on and on. The blue squares represent each blockchain node, aka each individual ledger. The amount of nodes will increase as the amount of proprietorships increase. These nodes can either be running at each of the healthcare companies or in a cloud provided by a managing company, and this would be dictated by privacy protection laws. It can be a heterogeneous deployment environment, much like the internet itself. It's important that all the nodes are not found all in one physical space. A challenge for this solution is that they all need to be composed of the same language, for example, Hyperledger or Fabric, to talk to one another, and implementing this solution over a massive scale would be rather difficult, but in turn, its function is a lot more efficient. Now, let's talk about the physical code of the blockchain. This blockchain is obviously going to be incredibly complex. You could have up to hundreds of thousands, if not millions of blocks written every single day. One block could consist of a doctor amending to a patient's medical records. Another could be a drug manufacturing company transporting pharmaceuticals from point A to point B. Another could be an insurance company editing the coverage of an individual. The list goes on and on. When a blockchain is this massive and deals with this many variables, you run into a lot of issues with organization and querying data. So how do we deal with sorting all this massive amount of data and still being compliant with HIPAA laws and privacy protection laws that obviously exist in this day and age? It's actually pretty simple. You simply create a user system with individual users that have different access levels to portions of the ledger. For example, a drug manufacturing company can only see information that is necessary for them to operate, so on and so forth for their respected company type. Another challenge that comes up is that this blockchain will obviously have a massive sheer size, and data access and retrieval could end up being slow and possibly difficult. There again is a solution for this. Through the engine that I've selected, BigchainDB, you can actually create a blockchain that writes to another blockchain or a separate database. And this will all depend on the data type that is entered. These databases, or secondary blockchains if you will, would have to still exist outside of each healthcare organization when it comes to privacy law. With that being said, I've chosen a blockchain architecture that consists of a decentralized ledger that has the ability to write to technically another decentralized ledger and so on, or another database. Doing some research, I've actually found one that exists. It's called BigchainDB. It also has the ability to set up customizable access, transactions, and permissions to specific users. I also selected an architecture that has the ability to write new blocks with low latency. This will help with the times required to construct each block, as well as query data from the original blockchain or secondary blockchains / smart databases. The biggest question is, why did I choose to go this route? One huge problem that definitely exists within our medical field right now and our healthcare field in general is documentation. Going this route, one can simply design a graphical user interface that has the ability to write different blocks of a blockchain when each action is submitted, and then through automation it's stored correctly in the correct area where people can then go back and look at it if they need to, as well as order things like a prescription or new drugs or new medical equipment. Data retrieval will also be incredibly quick, a lot quicker than it is currently within the healthcare system, and data would just be simply better organized. Another important thing to add is that transactions can easily be confirmed, whether that's from a doctor to a patient, a research company to the government, or an insurance company to a claim. All in all, essentially what you have is an incredibly complex blockchain originally that isn't really streamlined to creating automatically a streamlined blockchain for each individual proprietorship within a healthcare system.